Good day, everyone. Today we are going to talk about wave equations. Wave equations. We can represent wave equation that for a particle that starts from origin using the equation y is equal to a sine theta. And the graph here can be used to describe that. If a vibrating particle begins from origin, going, coming, down, going up, and all that, and if the wave begins from origin from here up to any point somewhere here, the vertical displacement is y. Y, the horizontal distance covered is x. And the distance between two successive crests is the wavelength. So, this graph here, the y is equal to a sine theta. Y is vertical displacement of the vibrating particle. A is the amplitude. Amplitude A is the maximum displacement of the vibrating particle. This theta is phase angle, and phase angle is obtained from angular frequency, which is equal to angle moved through in a given time. This means that theta here is equal to omega t. And of course, omega t, which is the angular frequency, is equal to 2 pi f. And so you now add this t, it becomes phase angle 2 pi ft. Therefore, this equation here can be represented as a sine 2 pi ft. And this is, let's call this equation 1. And speed of the wave, v, is equal to distance covered by the wave in a given time. And also, this horizontal distance, x, is equal to vt. Therefore, t is equal to x over v. And since v itself also is a product of frequency and wavelength, substituting v is equal to f lambda in this equation, then equation 1 becomes y is equal to a sine 2 pi f. Instead of t, we'll replace it with x, all over. Instead of v, we'll replace it with f lambda. So here, f will cancel f. Equation here becomes y is equal to a sine 2 pi x here, all over lambda. Let's call this equation 2. So equation 1 or 2 represents the displacement of a particle y that begins from origin. On the other hand, if the wave did not start from origin 0 here, supposing it started from any other point other than 0, then equation 2 becomes y is equal to a sine 2 pi all over lambda times x minus vt. Let's call this equation 3. Here, the horizontal distance, there is a difference. We subtract the distance, assuming the particle is somewhere here. The distance here is vt, because vt is actually horizontal distance as well. So there will be a difference in the distance. So if we expand this equation, y becomes y is equal to a sine 2 pi x over lambda here minus this term will also multiply this. It becomes 2 pi vt all over lambda. And we can call this equation 4. Here, we know that this vt, from what we know, v, from what we know, v is also the product of frequency and lambda. So substituting v is equal to f lambda. Equation 4 becomes y is equal to a sine 2 pi x all over lambda minus 2 pi. Instead of v, we now put f times lambda times this other t all over lambda. So here, lambda will cancel lambda. What remains is y is equal to a sine 2 pi x all over lambda minus 2 pi here f t. We can call this equation 5. Equation 5 can also be written as y is equal to a sine this 2 pi ft minus this one, then 2 pi x all over lambda.